Lots of people.
I know the meeting is almost ready to start, and we've already had the blue sheets go through once. It's a good sign. So actually, it is 5:40, so let's get started. Thank you, friends, for being here for this, our second session of IDR. Like the previous session, we're not going to go on and on from the chair. One thing we did want to talk about for just a minute is auto discovery. And, you know, as those of you for whom this isn't your first meeting will know, we have touched on this topic multiple times over the last couple years. And a couple days ago, one of the authors approached me and said, "John, are we going to do this work or what?" And I said, "Yeah, we're going to do this work." And thank you for bringing that up. But the deal is that we haven't successfully really driven to conclusion on what. So it's pretty clear to the chairs, and if you disagree with this, let us know in person, at the mic now, in private, whatever. But I mean, we're pretty sure that there's interest in the working group to work on this auto discovery thing. Last time we tried to reach consensus on a specific draft to move forward with. We had some interesting discussions, but we didn't have a clear conclusion. The good news is if you go back and look at the different drafts that were proposed, and I think that, in various flavors we got up to at least 4 of them. They're all pretty close in terms of semantics. They all look more or less like, let's exchange the data necessary to bootstrap, hold on just one second, to bootstrap a peering, and then let's, move forward from there. AC, yes, please go ahead.
There's a simple reason for that. John, AC Linux Cisco Systems. They all copied mine.
Exactly. When you care enough to copy from the very best, that's...
Don't hide your eyes, plagiarize.
Yep. Yeah, if anybody would like to do Tom Lehrer impressions later, at the bar, please do. Okay, so yeah. But we've got, there are a number of important differences between the various approaches and things that just haven't gotten nailed. So rather than having, several different teams of authors continue to work on their own drafts and then, debate about it in the working group, our tentative conclusion is maybe this is time for IDR to actually charter a design team to get together and say, we're 80% converged anyway, let's converge onto one proposal, bring it to the working group, and do it by the next IETF. So that's our proposal. We hope to put together a design team in the next couple weeks. If you're interested in working on it, please approach the chairs. If you have suggestions for how it should operate, that means you probably should also approach the chairs. We would like to do a solution that is pragmatic, because there's obviously been appetite for this for a while now. Let's get it done, and then we can iterate forward. So it does not necessarily have to solve the generic ultimate protocol problem. It just has to be useful for some of the important use cases. That's about it. We'll keep the working group updated. It's our intention to not have this be, a long-lived design team, like I said, hopefully to conclude by the next IETF and report out. If you have questions or comments right now, the mics are open. Otherwise, we can continue forward. Please go ahead.
Randy Bush, IJ Narcus, conclude by the next IETF. Is Vancouver being canceled?
Sorry?
I don't think you're going to make Vancouver.
You think that I'm over
I think
ambitious?
that's an unrealistic goal.
Okay, well, I'm famous for setting unrealistic goals. We thank you for the feedback. You're probably right if you say that, because you've done this more times than I have. We will at least have a report out by the next IETF. If it's an interim report, then so be it. I mean, obviously, the conclusion of the design team, at least my expectation is, the design team is not to present the working group with a finished product. The design team is to present the working group with a 0-0, at which point we will proceed forward. But your point is well taken nonetheless. Thank you.
There is one thing. This will be held as open working groups and open meetings, meaning there'll be WebEx. That should allow, according to Alyssa, anyone who wants to participate. Read that as I don't think we'll be impacted by any restrictions for any of you.
Okay, June, please.
Hello, my presentation contains two drafts. Both are about the using BGP to advise IPsec config. So let's get started.
Okay.
Okay, yeah. So the first one is I made an update for my previous IDR BGP IPsec draft. So that update is based on the feedback. Oh, sorry, thank you. Feedback I received so far since last IETF. The first one, I replaced the color subTLV with the new IPsec configuration tag subTLV. The reason being that instead of being overload the color subTLV, it's clear to use a new subTLV for such purpose. Next one is I add some text on the selecting TLVs when there are multiple IPsec TLVs available. It's basically that when there are multiple feasible IPsec TLV in the update, you can choose one based on the most explicit, or we say shortest range address range match. And then there's next one is pretty cosmetic. So basically changing the crypto using the in the example of in the draft from the AES CBC to the like more modern crypto Cha-Cha and so this basically just cosmetic change. And also they changed title from BGP signal IPsec tunnel configuration to BGP provisioned IPsec tunnel configuration. And also add a section basically to outline that some what system should do in when the tunnel goes down, or when system should reestablish tunnel, and also add more content in the security sections. Basically says like IGV2, what kind of mechanism to prevent IGV2 level DOS attack, and so on. Also add specification and number of time each of this new sub TLV could appear in the given tunnel TLV. And so there's some clarification in the intro to just to clarify this draft is about IPsec tunnel mode. And then last one is that basically the traffic selector itself and the port and the port range are now coming from mapping of the IPsec configuration tag. So these are the updates. Then I write a new draft about using the IPsec transport mode with any type of any type of IP tunnel. So this one is a little bit different from current what they define in the tunnel in cap draft. Current tunnel in cap draft specifies how tunnel stack works. Like for example, tunnel X inside a tunnel Y, but the IPsec trans model is working a little bit different because it's really not a tunnel stack. It's really using same IP header, for the IPsec transport mode protection. So here is example, as you can see, different from the IPsec tunnel mode. Here, you don't really have a new IPsec IP header here. You will reuse the payload packets IP header, adding a ESP header, and then basically the IPsec protection is applied to the payload of the original clear packet. So it's like an attribute to existing IP tunnel. For example, in this figure, it shows the GRU with IPsec transport mode protection, but it could be any type of IP tunnel, like VXLAN or whatever. You could apply this IPsec transport protection. So the current tunnel in cap draft doesn't really address such use case. So that's why I wrote a new draft for this. I think we already go through this. So how does it work? So in this draft, I introduced a new IPsec transport protecting sub-TRV. The value of this sub-TRV is that is IPsec configuration tag as defined in the previous draft. When IPsec encapsulation TRV includes this new sub-TRV, it means that advertising router requires IPsec transport mode protection for the corresponding IP tunnel. So for example, if you have this IPsec transport mode protection sub-TRV inside a VXLAN tunnel TRV, which means that the advertising router requires you to use IPsec transport mode along with VXLAN tunnel to reach this particular route. So once the receiving router get this update and decide to follow packets to this advertising router, so he will use following IPsec config to create the child SA. So basically, you will use transport with ESP, and then the public and private routing instance will be the same as the packet to be forwarded, and the peer tunnel address will be the same as indicated in the remote endpoint sub-TRV. The local traffic selector will be the following address range will be the local tunnel endpoint address, the protocol and the port range coming from the IPsec configuration tag mapped value. Similar to the remote traffic selector, address range will be the address in the remote endpoint sub-TRV of the selected tunnel encapsulation TRV. The protocol and port range will come from the tag mapped value. And other confusion like transform, lifetime, those IPsec confusion also come from the tag map value. So this is quite a straightforward idea to have this IPsec transport mode protected tunnel added to the BGP. So lastly, I think because these two drafts is just the extension to existing working group draft, tunnel in cap drafts. So I hope we can working group can consider to adopt these two drafts, and the idea is pretty straightforward.
Stefan Nikowski, maybe question to chairs. With the two drafts, do you plan to obsolete 5566?
I didn't hear that.
Ah, sorry. I was asking if you are planning to deprecate 5566 if we are going through this draft. Because they are defining using an old way to do, for example, MPLS over IPsec or IP in IPsec, yeah.
I think the answer, I have a few questions for him. The old IPsec tunnels work slightly different in my mind, but I may need more clarity. I don't think we should. I think they work different is the answer, but I may be mistaken. So before I can do a working group last call or adoption call, I've got to figure out how much overlap. Last time, my understanding from the SEC folks is that they made some suggestions for it. So I hope you'll be glad to read it as well and give me your opinion, along with the other vice chairs.
Okay.
I have a little bit of a different answer. I mean, not contradictory, but my answer is, does anyone here know of any reason why we shouldn't obsolete 5566 if we adopt this work? You can answer later.
This is Linda Dunbar from FutureWay. I have a few questions on this. So how do you distribute this BGP update? Because when you talk about IPsec between two nodes, right, you're going through public network. So from A, say we have 4 peers, how does he send this update to B?
Oh, so just BGP, right? Just regular BGP update
Well,
mechanism.
But regular BGP is transported through trusted domain. So here we're going through untrusted. So this message, this BGP update from A, do you just suppose to, as an internet package, just IP packet to send it to B through public internet?
Yeah, this is just BGP itself, just the control plane protocol, right? So you're talking, yeah, I think your point is mainly on how do you safeguard BGP itself from like attacking, right? That's your point. Like there's multiple mechanisms in BG, like BGP-SEC, like outbound filter. You can use those to prevent attacking.
Okay, so no, not more than that, because this packet is not encrypted. Is it encrypted?
No, BGP itself, you can run BGP over IPsec as well.
Right, but you have much more information just than the AS number. I'm talking to my peers. You're talking about configuration, all the, like say you have A is in Singapore, B is in Beijing or in Dallas, for example. And you're sending this BGP update from Singapore to Dallas through public internet with your configuration.
I mean, this is tough to see that you don't really care. I don't really care if it's internet or not. It's just IP packets, right?
Okay, that's one question I have. Yeah. Second question, I read your new draft update. Yeah. You propose 4 sub-TLVs, right? So I see some of the sub-TLVs information already carried by the BGP update. For example, your local address, right? Local address, actually, you can be encoded in the next hop. And also, why not?
No. So the local prefix is not the next hop. I think you're talking about the local endpoint, tunnel endpoint sub-TLV.
Right, there's local.
That is not new. That's already included in the tunnel encap draft.
Hey guys, our time is pretty tight. So if you've got like specific questions about encodings and stuff like that, I'd like to ask you to keep that for the mailing list. Okay. If you have like fundamental questions, like your first one was more about the security properties, I think that's appropriate for our discussion time here.
Oh, okay. Thank you. My first one actually main concern because through the public internet, the BGP.
Right, and you do have someone in line behind you.
Jeff Eisen, this is directed mostly to Linda's question. So everything in the tunnel encapsulation attribute has this security problem in the sense of, the security properties can get away from where the routes have been injected. This means that you have to worry about securing this at your edges of your network. That is actually the tunnel encaps security considerations. And this is a section that the security ADs have given a little bit of scrutiny. They're not necessarily happy with our answer about trying to scope the stuff, but it's already discussed in the document.
Okay.
So Jeff,
my understanding is when you use the tunnel encap in the MPLS network or in the trusted network, and you are in the walled-in domain, so that eliminates some of the concerns. Yes, that's my thing.
Yes, and it does address it by having it on transports that are a little bit more localized. So
Jeff, I'm having trouble hearing you, and I do need to, so if you just raise the mic.
Sorry. To say it again, Linda is correct that transports such as MPLS do have the advantage that they're sort of scoped locally to a network, whereas this, or to pick an example, SRv6, which is intentionally supposed to be able to go across things like the internet, the security considerations do change a little bit, and I suspect at some point this is going to come back and make the security ADs make us ask harder questions.
Okay, so that leads me to my next question. Do you feel this draft answers all the security considerations that Ben gave you last time? Because that will be my check before I before we go through it. I have to also answer the IPsec. I have to answer the administrative.
I think I already replied every question posted in the mail list.
Okay.
And just to follow,
that you believe you've finished it and you answered on the mail
I
list,
believe so.
and your mail list comment is complete.
Yes.
Okay.
I finished.
I will need to. I read that. I thought I followed it, but I will need to do a deep dive. So this may take me a little time to prep for a working
problem.
group adoption call. I have 2 open items: the previous IPsec VPNs and this. So please give me a little time to do a little digging on this
no
before I.
problem, no problem.
Not that I'm trying to not do an adoption call. I need to do an intelligent one.
Understood.
yeah, and just to conclude my comments, I do think that this work is worth working on, but getting the security correct is going to be very challenging.
Thank you.
Okay. Thank you.
Okay. Hello, can you hear me? Okay. So this is the second time we're presenting this, and just give an update on what we have done so far. So the intention of the draft, it is really an informational draft. We have applied a SAFI for SD-WAN, and here we want to explain how this SAFI is used. That's it. And we will be glad to get, would like to get your feedback on how we use it, or maybe some suggestions will be even better. Actually, we already got some suggestions from some IPsec folks. So in this domain, you can see that we have a bunch of CPEs located in different locations. And the CPEs are interconnected by multiple types of network. They can have MPLS network, and they can also have internet, public internet untrusted. And they are in their own administrative domain together with the route reflector. So each of the nodes has the secure channel to the route reflector. Dave Correll had this good term, Confederated Ipsec. So it's different from the traditional peer-to-peer IPsec. Like if you do traditional IPsec, as Jun just mentioned, that you need to configure a lot more things. You not only need to configure yourself, you configure your peer, and you configure who is attached on your side and who is attached on the remote side, and you have to set up the tunnel peer-to-peer. In this confederated mode, each node don't even know who he is supposed to talk to. Basically, the security policy, the SAD, S-A-D, is managed by the route reflector, the central controller. This is for the SD-WAN case. A node is expected to be zero-touch provisioning. When he's being powered up, supposed to be running right away. So he doesn't even know who he can talk to. So he sends his own information to the route reflector, to the controller. And then with his own information, the route reflector decide who this message is propagated to. And in this domain, it's under the assumption everybody trusts his own controller, because this update is just a small portion of the entire scheme of things. Not only you trust the controller tell you who you are supposed to talk to, you also have other configurations like the traffic pattern, who your client is, and a bunch of more information, which is complete out of scope of BGP IDR. So in this domain, the node himself will do a regular BGP update to basically propagate his attached routes. That's basically his EVPN, his attached routes. He will use the BGP update, regular BGP update with NOI pass attributes to indicate all the routes. And if there are tunnel and whatever encapsulation, he may use tunnel pass attribute to indicate them. And then in addition to the regular BGP update, what he needs to do next is to be able to propagate the WAN port properties, because the WAN port property from node like CPE2 is not visible to the remote node, right? Remote node doesn't know. So what he does need to do is be able to propagate the WAN port properties, including the public routable address, because this PE2's port 2 get assigned address from ISP, like for example, Verizon or China Telecom. And so he need to tell them, who am I, my identity, and then send that message through a secure channel to the route reflector. And route reflector will propagate that information to the remote nodes, will authorize remote nodes. In the so in the NLI, the pass attribute, you will give the identity of this port, the WAN port. And in the pass, the tunnel in cap pass attribute, you need to include the net information. You need to include IPsec information. If there's a certain application can only be have certain topology, you may need to indicate that as well. So that's basically how this new NRI is used for identify the WAN port. That's it. The tunnel in cap is pretty much same as before. So for the WAN port identity, there will be several attributes to uniquely identify this WAN port. So there will be port identifier, right? This port identifier may be locally significant. The node may only know, oh, this is my number 1 port, number 2 port, number 3 port. And there's another attribute could be, where am I? I'm in Singapore, okay? I'm in Dallas, for example. Basically geographic location of this node. Whatever this provider need to decide on, they will use their specific identifier for their site location. Another one is the routable address, meaning how can anybody else reach you, right? See, if I'm here in Singapore and my peers in Dallas, and they had to know how to reach me, it has to be a routable address. So that's the node ID. Address, okay? Those 3 attributes uniquely identify the port. Here is the sub-TLV for the net. So basically, you need to indicate what kind of a net type it is, and you need to indicate how your panel associated property associated with net. Here is the information to be carried, minimum information. We're not talking about full suite of information for IPsec, but minimum information that this node need to pass to his controller. Actually, I took most of the information from Dave Carell's draft. Basically, you need to include what kind of, whether it's AH or ESP, whether it is your public key, right? You have to tell everybody your public key. You have to tell them the key counter. This key is the first time or second time. And you need to tell the controller your nonce. And you may have another indicator you probably want to tell. So I have another field, the key 3 there, just for additional field. That's it. And that's the minimum ones. If this end node need to establish like route-based IPsec tunnel, you can also do that. Actually, you can use Houdrin's draft to be able to establish route-based IPsec tunnels. So next step, we'd like to call for working group adoption. The reason is to be able to demonstrate how BGP is used to do the port-based IPsec and to scale the SD-WAN overlay network.
So I guess I have 2 questions. One is you say it's to demonstrate how BGP is used. Do you really mean like you want to ship a product that actually does this, or do you actually mean you just want to use it for a demo?
Both.
Okay,
so show the capability, because today people use NHRP and use DMVP and DHRP. NHRP.
Please use
Okay,
the mic, sorry.
so today people use NHRP. Actually, it's modified NHRP. NHRP is for ATM. So they modify it. Many vendors does that. And it's okay for device just supporting that. But for device already supports BGP stack, is much easier and simpler.
Okay, I was just getting hung up on this word demonstrate, but
okay,
I think that
right
really
word.
what you're saying is you just like the solution, you want to ship the solution, you think it's a worthwhile solution. Yeah?
It's worthwhile, yes.
Okay, and then that leads into the second question, which is your intended status is informational. Is that you don't want it to be standards track?
Well, I just feel like informational is just to show this is in the first come first serve range of the SAFI, and just demonstrate how it's used.
Okay, I mean, just because it's FCFS doesn't mean that you can't ask for a standards track.
Would that be too difficult?
I mean, to me, this looks like standards track work. And I would think that if the working group, I mean, I guess if the working group were going to adopt it, my inclination would be to say this looks like standards track.
Okay. Actually, I'm going to work with David a little bit afterwards and see if his draft, like he has this draft, and if we want to take the content for his content is device information message, that specific content of that merged together with this draft, then that definitely can become standard. Yes.
Actually, John made the same point I was going to make about the informational. I read the draft on the plane and I didn't even realize. I thought it was standards track.
Okay.
And I didn't check to see that the SAFI was a FCFS IANA, so I didn't know that you wouldn't need a document to allocate one. I mean, it wasn't apparent to me, but no, I understand. Okay.
Thank you. Thank you.
But that's a good question. It does look like standard. In reading it, it looked a lot like standards track to me too.
Okay.
So I agree with that.
Okay, so I'll work with David if that's his component can be merging with this one. Then we can. Okay. Thank you. Thank you very much.
Thanks, Linda.
Is this a duo?
Yeah.
Oh, I like this. More entertaining.
So yes, there's been a lot of interest in this draft in the last 3 months since Montreal. A lot of good discussion on both the IDR list and the GROW list. A lot of good feedback. So Warren and I were keeping it alive for the last maybe several years, but now the interest has picked up. In the last 2 months, we have had 2 updates of this draft. Jeff offered some very interesting slides with good insights regarding the AS set implementation and how that results in some of the quirky behavior that we see in the measurements. He also offers in a couple of his slides some pretty good advice or operational considerations items. So he's going to pick up on from some of the slides and speak to them. So tremendous interest in trying to get this done, deprecate AS sets and AS confed sets. At NIST, we have been doing a great deal of measurements, and the measurements show that out of 800,000 routes, less than 500 have AS sets in them, so a minuscule percentage. And if you start looking at them more closely, we've done a pretty detailed analysis. The link is at the bottom. If you look at them closely, only 21 have meaningful AS sets, and the remaining 450, so 450 or so, they don't seem to have meaningful AS sets.
Do you know why, before you go off of that, since that's an interesting statistic, do you know why you have these malformed?
Jeff's slides get into that.
Oh, goody. I'm a straight person.
So part of it is implementation quirks. Then we looked at aggregate, atomic aggregate, aggregator, atomic aggregate. Out of, again, 800,000 updates, about 10% have aggregator in them. And out of the 76,000 or 10%, less than half of them also have atomic aggregate. Let Jeff speak to the next.
So the interesting thing we're seeing in the stats is that roughly 10% of the internet is using a knob that is resulting in aggregation of routes. So this is proving that this is actually a dangerous thing for us to be touching if we're actually going to get involved in the specs. This is really my feedback that is generated this set of slides, that if we're going to actually try to get rid of this, there's a lot of implication on a lot of documents. And if we get it wrong, well, you're impacting 10% of the prefixes on the internet, and that's obviously a scary thing. But looking at specific data sets, one of the things that we see is these weird things where we have a single AS at the end that has a set element in there. And we have 4271 actually tells us how we do this. And Jared Moch was actually very kind to send some routes from his network that demonstrated one of the reasons we get into this. A simple example is that consider a set of a set of routes that have a null AS path. This is strictly internal. And then you have similar set of routes that have a single AS in there. If you do aggregation by the current rules, the longest common path is 0, and everything else gets tossed into a set length of 1. Now, what's sort of interesting for these things, it is potentially possible in such a case to maybe merge this into the actual AS sequence that's right next to it. In that case, the length would be preserved versus what we actually see of the set on there. But the question really becomes whether this is preserving the actual origin intent, especially since the whole point of this exercise is people don't like this because of its impact on RPKI. So the two observations here is that in the case where you may actually have, in the case of an AS followed by a set of the same AS, the merge operation as sort of an optimization may make sense to preserve the length. The other observation is pretty much the brief style of aggregation, which has been implemented by pretty much every implementation of BGP aggregation since the 1990s, will actually make this correct.
So this picture is just to make the point that as long as AS3, which is aggregating P1/24 and P2/24 into a P/23, as long as AS3 does not announce the less specific to AS2, and even though AS4 may announce it to AS2, so horizontal is lateral peer-to-peer, and slanted is customer to provider. So even if AS4 announces the less specific to AS2, AS2 will still be fine because it installs the less specifics that are necessary within the more specifics that are necessary within the less specifics. Operation at AS2, the overall operation will be fine. Only problem arises when if P2/24 gets cut off, then there's a possibility of data packets looping for a brief period of time, and that goes away when the recovery happens, the network recovers, or AS2 decides to deaggregate because it doesn't have one of the contributing more specifics. So with the aggregator alone and without using AS set, things seem to work fine generally. So in the draft, we have this must and should. We are still debating that. We do say that if you are locally, you must not, or the router must not locally generate BGP update messages containing a set, AS set or AS confed set. And we do say also that upon receipt of a message of such kind, the conformant BGP speaker should treat as withdraw. So one question is, would the working group like to see that change to must, just use the stronger language and deprecate it without allowing any room for use of AS sets under any circumstances? And that would help things like RPKI origin validation, BGP sec, and Alexander's ASPA a great deal, not having AS sets in the updates. So there are two choices here. Jeff is, as you will see in the next few slides, he thinks that it is possible to just have a BCP with the operational considerations clearly specified. On the other hand, we can do a change to the existing RFCs that talk about AS set, AS confed set, make it a standards document which updates these other documents which has AS set and AS confed set on them in them, and it's doable. I have identified how many mentions of these things are there. We can go and make specific recommendations regarding wording changes. So that's doable.
So just if you go back to that, I'd like to add something. Avera and I were just discussing the fact that there is some desire to see RFC 4271 head toward its internet standard. And some of these might follow along the same way. That is one of the projects that I'll send to the working group. It might be the time to do that since we would have to do it anyway. Mm-hmm. And I had a lot of pieces. So this might not be the problem you're thinking. Okay. That was something we were talking about in the charter. If you hate that idea, do come tell the chairs. The idea, if we do an internet standard, is not new features, but to document what is existing and out there. Just so I...
Hey, we're Krishna, hold the questions just 1 second. So the feedback I had given is that if we are going to touch these specs, it is deeply intrusive and we have to be very, 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 very careful about them. And a number of us spent a lot of time getting these right. The alternate path for standardizing this or BCPing this is, we're saying, pretty much every implementation does support brief aggregation. So no new code is actually needed to do the correct thing here. Convincing your vendor that a default knob needs to change its behavior, that's a different question, but in terms of the functionality, it is already present. There isn't any need to necessarily change any RFCs. 6472 came out some time ago and said, stop doing this. Well, the knob to stop doing this is brief. Implementations, it is reasonable to ask the vendors, including the person that's standing at the microphone here, to add policy such that AS sets can be matched within the policy engine so that you can implement, drop this prefix if you so chose. And somewhat in the absence of people actually doing any of these things, RPKI filtering is becoming more and more common. If people don't clean up their own act and their own self-interest, they're just simply going to get their routes filtered anyway. This is a self-correcting problem. My sort of recommendation is that we take this opportunity and use the operational consideration section here and cover the facts of what happens with, what was sets actually there for? What does it actually prevent you in terms of receiving routes within your network and receiving your own forwarding? So, the behaviors that we see that are known, that are called out in the RFC, but aren't necessarily something you think through unless you're an operator. Aggregators, the person that's actually doing that needs to supply the more specifics to the contributing ASs. That's the behavior that was expected out of this when you're doing proxy aggregation. It's not documented anywhere. The entity that's doing the aggregation should not send the aggregate downstream to the contributing ASs. And that ASs that are getting aggregated probably should be rejecting routes that contain their own address space, and making sure that we have some sort of policy knob that's capable of doing that, is a tricky thing. I'm aware of from at least one service provider that they have a practice of taking their own address space and basically nailing up a black hole route internally for all of their own space. And this keeps traffic, in the case you actually do get some sort of aggregate route into your network from leaving the network. This again is not written down anywhere, and this is not a bad place to put it.
Okay, please keep comments brief. We are running really short on time. Thank you.
Jared Mach, Akamai. Thank you. Also, sorry for the AS sets that we found, and thank you for looking into it. If you find any more from us, we'd like to clean those up because those are definitely not an intended operation. And I suspect that's the case actually with the majority of the ones out there. I think that we probably want to deprecate this stuff, and it might be helpful if the vendors even delivered a soft knob where I could, on my administrative domain, say, hey, I'd like to drop these. There's drop path attributes options that exist on some vendors that allow you to drop those. And if I can drop routes, including certain path attributes, and being able to drop AS set routes, I suspect would allow people to update and correct their configuration. Okay. And the aggregate function, I think, has been, we've seen a number of weird issues with that, and we need to change the way that we're originating our routes as a result. But thank you for this.
Warren Kamari, Google. While I'm all for moving 4271 to like full standard, keep in mind it's a huge job and it's going to take a really, really long time. I've seen other protocols do it, and it's going to be much navel gazing.
I've rejected this 3 times before, Warren. But I think it's really neat that there be a short-term effect, because this needs to happen sooner rather than later.
I think I want to echo Jared. This is thank you. This is going to be a lot of hard work, but it's needed to be done. Couple of years. Igor Goshinsky, Verizon Media, Yahoo. A couple of years ago, like 8 or so, we went through a painful process of changing every single announcement that we had that was using aggregation AS sets to do atomic aggregate. So I'd like to echo Jared. Can you give people a knob that just says convert AS sets to atomic aggregate that would be session applied? And I think most of it could just be worked around kind of like that, because for most of us, it was just the default way of doing aggregation. We just say aggregate this. It came from 3 different ASs, and it just kind of got nailed up.
Yep. So I get it.
I'm going to call this the guillotine option. I don't think it's actually a good idea to go changing other people's AS paths, even though, obviously you could do such a thing.
No, a knob to do this on your infrastructure.
Yeah, locally, that's brief. Yeah. That's what the whole thing is for.
Yeah, so that would be very helpful to be able to do that. So if you're an aggregator and you got AS set as a result of you being an aggregator, just kill it. Because otherwise, at least right now, you have to go manually route by route on every router, and that takes time. But that's actually probably most of the misconfigs.
Rüdiger Volk, Deutsche Telekom. Just a short remark, I'll try. Seeing discussion about cleaning up certain historic artifacts and deprecating some of them, I would suggest we probably should be also considering to clean up as far as possible the 2-byte ASs showing up. I got the idea we should be thinking about it after once more this week having to comment that, creating complexity in new BGP stuff to take care of the of implementations that actually don't do 4-byte IS. That's a thing of the past.
Okay, so comments to the chairs. Basically, what we have is the original draft, which says let's proceed with deprecation. I'm offering an alternate path that's basically here's ways to take it forward as a cleanup thing. The working group will need to figure out which way it wants to go. I can contribute text either way.
Thank you. Yep. So as you will have noticed from my increasing, so we're done with this. Thank you. From my increasing agitation, we are running super short on time. So Ketan, I'm going to ask you, to just fly through these.
You can just say we're going to do a working group last call, and the chairs are going to look at it and sit down if you wish.
Okay. Building your time will be all right.
Okay, so this very quick, Ketan Talaulikar, Cisco.
So we have this working group draft. It's about SR policy SAFI for signaling of SR policies from controllers to headends via BGP. Now, it's been there for quite some time, and we are preparing for working group last call. It's a companion draft of the SR policy architecture draft, which is in spring and also close to working group last call. Implementations are around even deployments. So what we have done in this recent updates is taken care of some things to make this last calls smoother and go faster. So I'm not going to go into all of this because there has been some discussions on the thread and we are running short of time. So key points is error handling things have been consolidated in one section just to make it easier. IANA considerations has been updated to catch something which was missed out from the color extended community, and some minor changes to the allocation process. We welcome feedback. So this is really more of a heads up to the working group to review, provide inputs. Implementation reports have been updated with 2 implementations. So hopefully by Vancouver, maybe we can get it. The next one is the BGP, also working group document for BGP-LS application specific attributes. This will be even faster, hope. So just want to update the progression. So this was adopted and we have got code points and implementations are also in progress. The key thing which I wanted to point out here is that the underlying IGP specs are in the review, ISG review, and as they have been updated based on feedback, we have updated this spec to be aligned with them. Okay, so again, I'm not going to go into the details, but at a high level, that's all about what the changes to this draft is. So we're requesting for review, and once the IGP drafts go past the work there, ISG reviews, we hope that we can do a working group last call for this as well.
AC, are you here still? Yeah, there. When you look at it for IGPs, would you make sure that it still makes sure to be a standalone document with this being that this document should be a standalone document? You don't have to answer. Just we look at it.
AC Lindum, Cisco Systems LSR Working Group Chair. It should be a standalone document because the 2 IGP documents have gone so far.
Okay, thank you. That
I mean,
helps
they're actually in Albaro's queue for review. Okay. They've completed working group last call.
Hi, my name is Yimin Shen from Juniper. I'm going to present this new draft called the BGP Flexible Color-Based Tunnel Selection. Oh. No, not that fast. This way, sorry. So in inter-domain and segment routing, we're seeing more and more cases where network attributes and network resources are assigned colors, and colors used together with BGP next hop to map a prefix, a service prefix or payload prefix to transport tunnels. So in this case here, we have payload prefix with BGP next hop N and color red, and we map it to a red tunnel to N. There are 2 reasons behind that. One is that color is a very generic notion. It can be used to represent any network attributes. Second reason is that color encoded as a BGP community can be conveniently signaled across domain boundaries and can be signaled from controller to routers. So if we can assign colors to network attributes or network resources, we'll be able to create the color tunnels and color the payload prefixes. The color of a tunnel would be the color of the network attribute that based on which the tunnel is established, and the color of the payload prefix will be the color of the the color of the type of the tunnel that the prefix desires. So on top of that, if we can do color-based tunnel selection, we'll have a very generic service mapping mechanism. It can work in inter-domain environments and controller-driven environments. So a red color payload prefix mapping to a red tunnel is the most basic mapping mode. In many cases, we would like to have much more flexibility. So that's the purpose of this draft. In this draft, so this draft introduced a set of defines a set of extended mapping modes, and it talks about how to use these modes to construct so-called flexible selection schemes. Each scheme consists of a sequence of extended modes in the fallback order, meaning that you select your tunnel based on the first mode. If it's unsuccessful, you move on to your second mode, and a third mode, so on. So in this example, we have payload prefix with next hop n and color red, and the user may define a scheme and attach to that payload prefix. There are 3 modes in this scheme. The first one is color, IP color with fallback blue and green. So what this means is that we'll first attempt to find a red tunnel to N. If it's unsuccessful, we'll move on to look for a blue tunnel to N, and then a green tunnel to N. If the entire first mode is unsuccessful, we'll move on to the second mode, which is in this case converted IP color with a fallback blue, meaning that we're going to convert the IP address N to a IPv6 address, and then look for a red tunnel to that IPv6 address. If it's unsuccessful, we'll move on to a blue tunnel. If the entire second mode is unsuccessful, we'll go on to the third mode, which is IP only, meaning that we're going to just ignore the color and look for a uncolored tunnel to N. So there are 3 modes to provision a flexible selection scheme. First mode is called the Ingress provision mode. In this mode, we configure the scheme as a local policy on the Ingress router, and we apply that policy to the payload prefixes. Second mode is called the Egress provisioning mode. We configure the scheme on a egress router, and then we use BGP to signal the scheme with the payload prefix to ingress routers. And here we're using a new path attribute called the flexible color tunnel selection path attribute. And then on each ingress router, we apply the scheme to the associated payload prefixes. Similarly, we have a third mode called controller provisioning mode, where the controller will signal the scheme by using the new path attribute to ingress routers, and then on each ingress router we apply the scheme to associate the payload prefix. This shows the encoding of the new path attribute. It consists of a sequence of extended mapping mode TLVs. Each TLV has a mode value, and it may optionally have a list of fallback colors. So this list of fallback colors apply to some modes, not all the modes. Okay. And the segment routing policy draft and IDR segment routing policy draft defines 2 so-called color-only bits in the color extended community, and defines 3 fallback modes. Compared to that, this draft just provide a more flexible and extendable mechanism. It fully supports the fallback mode predefined by the 2 drafts. In the case that a flexible selection scheme and the CO bits coexist, if the scheme is defined as a local policy on the ingress router, will give preference to the local policy. If it's received by the new path attribute. And in that case, we're going to give preference to the CO bits. So next steps, we'd like to encourage the working group to review and to provide your feedback.
I have just a few questions for you. Number one, have you shown this particular scheme to the Spring folks who are working on the other drafts with policy?
We have not.
Okay. Yeah. That might be at least wise since you referred to it. Secondly, can you compare and contrast it with the use that, other than the IPsec portion, that June was using for his color?
The tunnel incapped path attributes applies to a prefix that's tunnels are built upon, right? Specify.
Actually, I'm sorry. Can I ask you two to take it offline? Because we're actually out of session time. We have one more thing on the agenda. I will ask people if you have 5 minutes, please give us 5 more minutes, please. We did have. Go ahead. I'm just, as you're setting up, I'm going to make one other announcement, which is we had one extra talk that came in late. We put it on if time allows. Time is not going to allow. I'm sorry, Lewis. Group members can look on the meeting materials site and see the slides.
Okay. Hello, I'm Haibo Wao from Huawei. Now I will introduce the destination IP Orange AS filter for BP flow spec. Why I need this? Because now flow spec is used for adjust traffic more and more. Some operators give me some requirement that they want to adjust the traffic for special AS from one side to another side, such as they want to adjust the traffic from R2 to R3. In current method, we also can do it, but we must generate multiple flow spec routes and send it to the router. We will use for example, we will use the SIP and the DIP and multiple to do this. But we propose the most is that we use one route to instead of multiple. We use a destination IP Orange AS route to instead of multiple destination IP address. This have some benefits. For example, it's easier for operator. And also, it will reduce the messages for from server to router. And also, it may reduce the number of flow spec table entries. We now use a new component type for DAS. And for this component type, we suggest method to realize it to look up FIP, then get the DIP, the Orange AS, and then use the DAS to match this rule. Also, it may have another option to expand the DAS to multiple DIP-based rules. And there is a application and evolution that we may combine the new component with the existing flow spec components for traffic matching. We combine with many types. And also, more new types we want to introduce, such as source IP Orange AS and destination IP community or source IP community and others. And we also have received some comments. There are two many considered. One is the security consideration. We think that we may use capability negotiation for direct connection between routers and flow spec servers. And also, we may use BMP to connect the router capability. Then the server can control whether to send the new component type to the router. Also, we may use the node target to control which router can receive this new component type. And another question is that whether we will use the new SAFI for this component type, but because now the new component type also provides a match criteria under flow spec architecture. And also the component type may use together with the existing component type, so we don't want to use a new SAFI. Later on, we may welcome for comments. Thank you.
Jeff Haas, I'm going to just make the point that my list comments stand. Please review the comments on the list for context, but you have mischaracterized my objection. My objection is that FlowSpec operates on firewall rules. You're reaching across the boundary between the firewall and the RIB.
I agree, AC Lindum, especially you have the AS origin, and I think, okay, you're pushing that into the FIB. Then you say we could do all these other rules too, and I'm thinking, oh my God, you're going to put all the BGP attributes into the FIB? No.
Same command, and IS number or any other BGP attribute is never in FIB. Your interaction with best path selection, and be clear about that. It's not a good idea, by the way.
If we do not consider expanded condition to many, we can consider only the as number, because it can take the flow control more flexibility, and the S option exists in the current FIB table. Okay.
Jodong from Huawei. Actually, I think we in this draft it provides two options. One is you match the destination AS in the FIB. Another is you can expand this to several rules in the device, but you just need to advertise one from the server. This is two options.
Okay, I would like to close the conversation
implementation
now because we're 5 minutes over. Thank you, everybody, for sticking it out. Sorry for running over our time twice in 1 week. We'll try to do better next time. Hope to see you all there. Please, I know we've had to cut off several conversations. I hope you continue them on the list or out in the hallway. Thanks again.